So in our last video we have discussed about the Fourier series that expresses all the complex functions in terms of two or more simple functions as an addition. So proceeding after that, we will now discuss the same thing ft here also and ft here also. So taking the simplest form, ft is equals to a sine omega t. What is this omega here? So you can see here that it is 2 pi by t. So omega is equals to 2 pi by t here, plus b sine omega t. This is for 1, since it was a n and b n cos 2 pi n sine 2 pi n by t. So putting n is equals to 1 means for first term ft is equals to a sine omega t plus b sine omega t, considering a to be r cos phi and b to be r sin phi. Putting this value here, we get r cos phi sin omega t plus r sin phi cos omega t. That will give you r sin omega t plus phi, since it is a formula. Taking r to be common, sin a cos a sin b plus sin a cos b. So this gives the value sin b plus a or sin a plus b. Now calculating the value here, r is equals to a square plus b square. How does the value of a square plus b square came? By squaring the value. By squaring this and this, we will get a square is equals to r square cos square phi and b square to be r square sin square phi. Adding on both of these, so cos square phi plus sin square phi becomes 1. We get r square is equals to a square plus b square, or r is equals to a square plus b square under root. So by this we get the formula also by dividing this b by a to be r will be cancelled. So we will get this tan phi is equals to b by a. Now let us discuss about what is phase. Suppose if one particle is moving in this direction and other particle is moving in this direction. So both are having different directions. So these can be said to be having a phase angle of 90 degree. So basically what does a phase tells you about? It tells about the position and direction of motion of the particle. So therefore it can be defined as the physical quantity which completely expresses the position and direction of the motion of particle is known as phase. If we talk about oscillatory motion, since the chapter is all about oscillatory motion, so the oscillatory motion, for oscillatory motion, phase of vibrating particle is just sine or cosine function. Means y, that is taken to be the movement or motion as a function of this is a function of time t. So y is equals to a sine omega t plus phi naught. Phi naught is the initial phase, initial status of the phase. So this, in place of omega we can write a 2 pi by t. So this value is telling you the phase. This is phi. Phi is equals to 2 pi by t time into time plus phi naught. So when t is equals to 0, when t is equals to 0, phi becomes phi naught, says this term completely becomes 0. This condition, when phi is equals to phi naught, means initial phase, initial condition is known as epoch, or also known as initial phase. Now what is the phase difference? Means lack of harmony in vibrating states of two particles. Means If one is vibrating in this direction and other is that moving in this direction, so there has to be some difference, lack, means they are not parallelly moving, but they are lacking the harmony, the synchronism. So this, therefore, the angle subtended by these two particles, means the motion of these two particles, will be 90 degree. So the phase angle for this could be taken as phi is equals to 90 degree or pi by 2. Now, to understand this clearly, let us discuss about some specific kinds. So let us take, initially one particle was moving in this manner, and other particle shown by the red one is moving in this manner. Now you can see the point at which both started is synchronized, and when they are coming back to the initial state, that is at zero value, it is also same at same time, and again these are reaching the maximum point at the same time. So we can say that uh, the value of y or motion is given as a sin omega t and b sin omega t. Why b? Because the amplitude is different. This is b and this is a minus a. So this will be a. This complete one is a and this is b. So the phase difference between these two could be considered to be 0. So phase difference is 0 here. Now if a particle is moving in this manner and other is moving in opposite manner, means when it is at maximum height, at maximum amplitude, the second particle is at maximum negative amplitude. So in this manner, the phase difference could be considered as 180 degree. Okay, so you can consider it to be this, and in this, okay. Now in this condition, let us say that the particle is moving. When the particle is at highest peak, the second particle at that point of time was at 0, and when the first particle reached it to 0, the first particle was at highest. So there is a small change in this also. So it can be represented by y is equals to a sin omega t, and y red one is equals to b sin omega t minus pi by 4. Why pi by 4? Because this 180 could be written as pi. So you can clearly see the value is reflecting here. So y is equals to a sin omega t plus pi. Since plus pi indicates that it is pi phase ahead of the initial wave. Now since this is minus here, means it is pi by 4 lagging. So this is lagging and this is leading. Lagging means that is coming behind and this is coming in forward, advance. Now the second, you can see that there is pi by 2 plus, means the first one is phi is equals to pi by 2, that is lead for first one. So in this manner you can see the phase difference of different waves. Now let us move on to the other concept, that is simple harmonic motion. So what is this simple harmonic motion? See, simple harmonic motion can be treated as to be a simple oscillatory motion. What does it say? It is the to and fro. It is to and fro movement under a restoring force, such as pendulum, such as a spring, such as a floating cylinder. All these substances do simple oscillatory or also known as harmonic motion. And this motion is directly proportional to the displacement from the mean position. Suppose this is your mean position, as much as the displacement is this, with increasing displacement from the mean position to the extreme position, the restoring force will be acting much higher, means that more will be the displacement, higher will be the force exerted by the restoring force. So a restoring force, this is restoring force is directly proportional to a displacement from the mean position, but the direction of displacement and force is just opposite. So F can be considered as minus kx, where k is force constant or spring factor. So we can write in place of F to be ma, where we get the value a acceleration is equals to minus k by mx, means acceleration of the particle is also depending on the displacement. Higher the displacement, more will be the acceleration. So what is the characteristics? Characteristics of a simple harmonic motion is that it is a periodic motion, simplest oscillatory motion, where F means restoring force is directly proportional to the displacement from its mean position, and the force it opposes, basically the minus sign indicates that force is acting in opposite direction, means it opposes the increase in the more the increment in the displacement, higher will be the force in opposite direction. And it can be always expressed in the sign of function, sine function and cos function, means always it can be seen that, so you can see that first the values move coming to be positive, then negative, then positive, then negative, so it can be considered as a simple harmonic motion. Similarly in the case of cosine also. So this is sine function and this is cosine function. Now let us move on to the other topics, that is key terms of SHM. What are the key terms of SHM? Displacement is nothing but the distance from the mean position at that instance, means this is the mean position, and let us suppose simple pendulum, so it is moving, so distance from the mean position is known as displacement. This is the displacement. You can consider it to be x or y for spring. So y is equals to a sin omega t, x is equals to a cos omega t. Also considering the initial phase, y could be written as a sin omega t plus phi naught, and x is equals to a cos omega t plus phi naught. So if this is a sine wave, we can write the amplitude as the maximum displacement on either side, so this would be your amplitude also. Where a is equals to s by 2, means whatever be the swipe, this is s, this is s, complete, means displacement, complete displacement. This was your complete displacement, and the amplitude is nothing but the half of that displacement. Next, move on to velocity. Let us this is time rate of change of its displacement at any instant. So let us say y is equals to a sin omega t. plus phi naught. So for calculation of velocity, we can differentiate with respect to time. We get omega a cos omega t plus phi naught, since d by dt of sine is equals to cos and d by dt of omega t is equals to omega. So omega is written here and sine is differentiated as cos. So in place of cos, we can write the formula 1 minus sine square, since cos is equals to under root 1 minus sine square. So we can say in sine square omega t plus phi naught is nothing but y. From this equation, so from the value y is equals to a sine omega t, so this sine omega t plus phi naught can be taken as y will be here, a will be shifted to this side. So sine omega t plus phi naught becomes y by a. So in place of sine square omega t plus phi naught, putting this value from here, y square upon a square, with taking the LCM and all, a square comes here and the a comes outside, means a and a got cancelled, so the left part is only omega. So a square minus omega y square is the velocity. So this is your velocity. Now what is the velocity at mean position? The mean position, the y, there is no displacement, hence no overall average distance displacement. So the velocity is equals to omega a. This is not for the simple thing. This is not a simple motion. But at extreme positions, you can see y is equals to a, so velocity is equals to 0. As in case of simple pendulum, you can consider the velocity is maximum at mean position and minimum at extreme positions. Now let us talk about acceleration. Acceleration is nothing but the time rate of change of velocity. So differentiating with respect to time, the velocity we get omega, again omega d by dt of omega t is equals to omega, and d by dt of cos is equals to minus sine. So from this we get minus sine here, omega, again omega square, from this omega comes out, so omega square, and rest a sine omega t plus phi, and this is nothing but y. So a, this is the expression of a is equals to minus omega square y. So at mean position, what is the value? The value at mean position y is equals to 0, hence acceleration at mean position will be 0, means minimum. And at extreme position y is equals to a, so a is equals to always minus omega square into a. Why this minus? Opposite direction. Opposite direction, this acceleration does work. Now let us discuss about another thing, that is nothing but the time period of the simple harmonic motion. So that is the time period to complete one vibration. So t, since omega was 2 pi by t, so from this we can reshuffle time to get 2 pi by omega, and 2 pi by omega, this can be written as 2 pi y by a. How does this y by a got? Since see, a is equals to, initially just acceleration, the formula for acceleration was omega square y, ignoring the negative sign. So a by y is equals to omega square, means under root a by y is equals to omega. From this was 1 upon omega, so we get under root y by a. Y is nothing but the displacement and a is nothing but the acceleration. So time is equals to, for simple harmonic motion, it is 2 pi under root displacement upon acceleration. So what would be the frequency here? 1 upon t. 1 upon t is equals to 1 upon 2 pi under root acceleration upon displacement. The reciprocal will be done. So if we observe the graph, this is dt graph, displacement time graph, velocity time graph, acceleration time graph. So for a displacement time graph, the maximum value reaches to a at t by 4. At t by 2 it reaches to 0, means at, you can say, at mean position. This is the extreme position. Similarly, at this point, at t by 4, you can see the velocity is 0. Okay, when the point reaches at maximum displacement at extreme position, the velocity becomes 0, as you have just observed. As in the case, yes, extreme position is v is equals to 0. So similarly, at extreme position, opposite extreme position, that is minus a omega, and at final position, at mean positions, it is a omega, this one. And the acceleration time graph could be given as, at t by 4, the acceleration is minus a omega square, the same thing, the expression for which we have expressed here at extreme position. So at the acceleration time graph could be given in such a manner. So this was basic things about simple harmonic motion. Next we will discuss about the energies related to simple harmonic motion. Thank you.